Okay, for problem 7, we're pulling a freezer up a 10.8 degree ramp at a constant speed while applying a force of 448 newtons parallel and up the plane. So we're going to go ahead and draw on our picture here. Notice it's given to us in kilograms. That's not a force, that's a mass. So if we want to calculate the weight, we're going to have to do that. I'm going to go ahead and line up my forces, which I know to be there, and draw in my picture as well, putting in the angle. It tells us that we're moving it up the ramp at a constant speed, so if the speed is constant, then we know the acceleration has to be 0. Right, so for part A, it asks us to find the magnitude and the direction of the frictional force. So to do this, we're going to set up our forces. The easiest way, I think, to do this is to look at the cheat sheet, although if you draw your picture correctly, you won't have a problem with this. So the problem gives us that the force up the ramp is 448 newtons. But we need to calculate the force parallel. To do that, we're going to use our formula that force parallel is equal to mg sine theta. So we're going to plug in our values for mass in kilograms, and then our gravity, which is always going to be 9.8 meters per second squared as long as we're on Earth, and then sine of our angle, which is 10.8 degrees. So just plug all this into your calculator, and once you've done that, you'll get an answer of 269.9 newtons approximately. So we're going to take those values that we have right now, plug in our force up minus our FP, which is 269.9 newtons. Force of friction is what we're trying to figure out. Make sure you distribute that negative sign. And then on the other side, I'm going to put a 0, and that's because the acceleration is 0. So anything times 0 is going to be 0. I'm going to go ahead and simplify, moving that force of friction to the other side to make it positive. And then it's just a matter of simple subtraction till I get my answer. So go ahead and do that really quick. And then if you have done this correctly, you should have gotten an answer of 178.1 Newton. Alright, for part B, it asks us to find the coefficient of kinetic friction between the freezer and the ramp. Okay, so this will be pretty simple since we just calculated the force of friction. We know the equation for force of friction is mu times the normal force. And so to calculate the normal force, we're going to use mg cosine theta, which I didn't write the theta in there for some reason, but there should be a cosine theta. We're going to plug in all of those values. 147 kilograms times 9.8 meters per second times cosine of 10.8. I apologize, that's so messy. But once we distribute this through, this is the answer that you will get. So we're going to plug in our force of friction from part A, and then also plug in the normal force that we just calculated, 1,415 newtons. I'll separate that there so it doesn't get so messy. And then we'll just solve for our mu to be 0.126. Alright, and now part C says that we are at a distance of 1.58 meters up along the ramp, and then we lose our grip. How long does it take to slide back down that ramp? So we're going to go ahead and set that up on the next page. Okay. So once we get to our next page, we're going to draw our picture again. I'm going to do it twice because it's a little bit of a different scenario here, but you can just use the other one really if you would like to. So we've got 147 kilogram mass sliding down the plane because we've let go of it. It tells us, again, that it's going to slide 1.58 meters down the ramp. And so we're going to use our cheat sheet to come with the equation that we will need to know. But you can also calculate this by just determining which direction the forces would go. So it's going to be the force, or FP minus F sub F equals m times a, or force parallel minus force of friction equals mass times acceleration. We know that the force parallel is mass times gravity times the sine of theta, and then we know the force of friction because we calculated that in part B of our problem to be 178 newtons. And then we're going to plug in our mass that was given to us in the problem. I'm going to go ahead and plug in everything we know here to eliminate any confusion. And then just making sure we are adding and subtracting correctly. We're going to solve to get the acceleration, or A, by itself, simplifying before we do so. So I'm going to go ahead and write in these numbers, and then divide each side by 147 to solve for A. So then I find that my acceleration is 0.63 meters per second squared. Alright, the next part and the last part to this entire problem is to use one of the big four equations that we have to solve for the distance. And we know to do this because there's no other way for us to get the distance. We can't use force, mass, or any of those Newton's second law equations to solve for this. So I'm going to use this big four equation, and I noticed that I crossed out that VI times t because we know that the initial velocity, that it's starting from rest before it falls, so the initial velocity is going to be 0, so that cancels out. So then the simplified equation is just d equals 1/2 a times t squared, and we'll plug in all the values that we know to solve for t to be 2.24 seconds.